Hello everyone, welcome to the course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to talking about what is channel allocation problem in data link layer, and we have to discuss about multiple access protocols in data link layer. These two topics we are going to discuss in today's session. First, let us see the overview of today's session. First, we have to discuss about what is channel allocation problem and what are the different channel allocation techniques are there. We are going to use in channel allocation techniques like static allocation and dynamic allocation. These two we are going to discuss in today's topic. At the same time, afterwards we have to discuss about multiple access protocols. What are the different multiple access protocols we are using in data link layer? Like this is a diagram for the multiple access protocols. See here. Here the different types: random access protocols, control access protocols, channelization protocols. These all we are going to discussing in today's session. And next we are going to discussing about random access protocols. See, these are the random access protocols like Aloha, CSMA carries as multiple access, CSMA by CD and CSMA by CA, collision detection and collision avoidance. These topics we are going to discussing in today's session. First, let us see what is channel allocation problem. Channel allocation problem. So, where we have to use this channel? First of all, channel is nothing but whenever sender wants to send some data to the receiver, we have to use some particular channel for sending the data. That is nothing but channel. This is a channel, that means nothing but it is a transmission media. It is also called as a transmission media. Where we have to use this channel allocation problem is for which particular user we have to use this particular channel is nothing but channel allocation problem. In broadcast network, this broadcast is nothing but number of users are there. Number of users are there. This is nothing but the broadcast network. The single broadcast channel is used to allocated to the one transmitting user at a time is called as channel allocation problem. So this is the channel. This is only single channel. I want to use this particular channel, means number of users wants to share this particular channel only to send the data. That is the channel allocation. That time there may be chance of collision occur. That particular problem is nothing but the channel allocation problem. When multiple users, these are the multiple users, these are the different users, use a shared network, want to access the same network. They want to access the same channel only for transmitting the data. Then this channel allocation problem is occur in computer network. Means whenever the multiple users want to send the data using that particular channel only, then channel allocation problem will arise. So, to allocate the same channel between multiple users. So, if we want to allocate the channel for all the users, some techniques are going to be used, which are called as the channel allocation techniques. Means, whenever all the users want to send the data at the same time, there may be chance of channel allocation problem. To overcome that, we are going to use the channel allocation techniques. For overcoming that particular problem is called as the channel allocation techniques. Let us see what are the channel allocation techniques are there. These are the two types of channel allocation techniques are there. Why we are going to use the channel allocation techniques? For efficient frequencies, at the same time time slots and bandwidth purpose, we are going to use the channel allocation techniques. There are the two types of channel allocation techniques. Those are the static channel allocation as well as the dynamic channel allocation. Static means what here? It is the fixed. Here is dynamic. Dynamically we are allocating the channel. That is the two types of channel allocation problem. It is mainly used in LANs and MANs, means local area networks as well as the metropolitan area networks. First, let us see what is channel allocation in static. Static channel allocation. What is static channel allocation? It is the traditional way for allocating the single channel. This is the single channel between multiple users. These are the multiple users want to send the data using this particular channel only. So, called static channel allocation. Static means this is the fixed channel. Using these particular channel only, these multiple users want to send the data to the receiver. That is the static channel allocation. This static channel allocation is called as fixed channel allocation. This is the channel. The channel is fixed. That's why it is called as the fixed channel allocation. Such as telephone channels, we are going to use. This is the real-time examples for static channel allocation. In real time, we are going to use the telephone channels, right? There we are going to use the fixed allocation, means fixed channel allocation for sending the data. This is the example for the static channel allocation. So, the FDM, frequency division multiplexing, and time division multiplexing, TDM, is also examples for the static channel allocation. How it is going to be examples for the FDM and TDM? FDM is talking about the time, FDM is talking about the frequency, and TDM is talking about what? Time. These two also examples for the static channel allocation. How it is? In these methods, either it is having the fixed frequency, if it is FDM, fixed frequency is going to be followed. Here the frequency is fixed here. And coming to time, it is having the fixed time. Whenever channel can be allocated, that time the fixed time allocating for the each and every user. Whenever going for the frequency FDM, we have to allocate for the fixed frequency for each and every device, each and every user. That is the FDM and TDM for allocating the channel. Using static channel allocation means fixed channel allocation. This is about static channel allocation. And coming to dynamic channel allocation. What is dynamic channel allocation? Dynamic means runtime, means whenever we want we can allocate that time only. That is called as the dynamic allocation. See here, it is not permanently allocated channel, means there is no not permanently for that particular channel, used as called as the dynamic channel allocation. So in this technique, there is no fixed frequency, there is no fixed time slot, means we are not giving any fixed time, we are not giving fixed frequency for that particular users. That is dynamic channel allocation. To allocate, the allocation is depends upon the traffic, means traffic. It is going to be depend upon the traffic, means where this channel, whenever the data is transferring this particular channel, either the particular state is busy or busy at the same time idle, means if it is empty or some data is going to be sent. That is nothing but based on the traffic. If the traffic is increases, if more channels are going to be sent, more users want to send the data, more channels are going to be allocated, more channels are going to be allocated. Otherwise, fewer channels are allocated to the users. Means based on the traffic only, we are selecting the channels for sending the data. Means we are not going for the fixed channel. It is for number of channels are there for sending the data. Means suppose if you want to go from one place to another place, there may be different routes for sending the data also, right? We can say if it is the busy, we can go for another route. That is nothing but the dynamic allocation. This can be used, categorized into two parts. That is dynamic channel allocation centralized way, at the same time dynamic channel allocation distributed way. Centralized means it is like as a client server model, means here the server is there, here the channel is there, all are connected to this particular, all users are based on these users only. These are the different users, based on these server only we are sending the data. Centralized dynamic channel, through these only we are sending the data. Distributed dynamic channel allocation means distributed, all, every user is going to be distributed, means this is peer-to-peer connection. Everyone is connected, each and everything is connected to all other devices. That is the distributed channel allocation. These two comes under the dynamic channel allocation. So, how the dynamic channel allocations are going to be assumed? See, these are some assumptions for the dynamic channel assumptions. See here, station model. First, what is station model here? An independent station means each station, this is the one station, this is the one station. Each station is going to be independent. It is not depending on the other station. That is the station model. And coming to single channel. Single channel is nothing but it is available for all communication. A single channel is going to be available for all communication, is called as a single channel. And collision. What is collision exactly? Collision means multiple users want to send the data using particular channel, is called as a collision. So at the same time, continuous or slotted time means there is no master clock that divides time to discrete time intervals. Means we have to give some slots for sending the data. We are not giving any slots for the sending the data. That time is considered as a dynamic channel. Carried or no carried sense means suppose this is the channel. If I want to send the data, first what we have to check whether this particular channel is empty or busy. Whether the channel is idle or busy, we have to check. That is nothing but the sense. We have to sense the channel, whether it is going to be empty or busy before transmission of the data. Before transmission only, we have to check the state. We have to sense the station, is called as the carried sense or no carried sense. This all comes under the assumptions for the dynamic channel allocation. And next we will see what are the MAC access protocol. First we will discuss what is MAC access protocol, that is multiple access protocols. So this is the diagram for multiple access protocols. These multiple access protocol again going to be divided into three types. First one is the random access protocol, and next one is the controlled access protocol, and third one is the channelization protocol. These are the three types of the multiple access protocols. See first, what is multiple access protocols? When the sender and receiver has a dedicated link, means sender and receiver has a dedicated link to transmit the data packets, the data link control is enough to handle the channel. That is multiple access protocol. Suppose there is no dedicated path. So in between sender and receiver, there is no dedicated path for communicating or transferring the data between the two devices. In that case, what we have to do? Multiple stations access the channel. So there is no dedicated path. This is the dedicated path. That is the static. There is no dedicated path. I can go anywhere for sending the data. There is no dedicated path. Multiple stations access the channel and simultaneously transmit the data over the channel. Simultaneously, I can transfer by using any channel. That is the multiple access protocol. It may create the collision and crosstalk. Suppose if there is no fixed time, fixed frequency for that particular user, what it will happen? There may be creating the collision and crosstalk. Crosstalk means what we say? Crosstalk is nothing but multiple users. These are the multiple users. These multiple users want to send the data using that particular channel only. Then there may be chance of collision. That is the collision. And what is about crosstalk? Crosstalk is nothing but one data frame is combined with another data frame. Data frame is combined with another data frame is called as a crosstalk. Means suppose in real time we have seen this one crosstalk means suppose we dialed for one mobile number. That mobile number is also right number only, but that is connected to another person. We call one mobile number that is connected to another person. Sometimes it may be crosstalk also. That is called as the crosstalk. Hence, multiple access protocol is required to reduce the collision. These multiple access, why we are using? To reduce the collision and crosstalk, we are going to use the multiple access protocols between the channels. Between the channels, we are going to use for these multiple access protocols for the collision and crosstalk. To overcome the collision and crosstalk, we are going to use the MAC protocols. See here, these are different protocols, like random access protocols. In that, we are going to discussing about Aloha, CSMA, CSMA by CD and CSMA by CA. Let us see what are the random access protocols are there. See, first one is random access protocols. What is random access protocol? See here, in these protocol, all stations are the equal priority. Each is having the equal priority to send the data over the channel. That is the random access protocol. In these random access protocol, one or more stations cannot depending on the other station. It is not going to be dependent on the other station. It control the another station also. Depending on the channel state means whether the channel is idle or busy, based on that only we are sending the data. Each station transmitting the data frame. However, if more than one station sends the data over a channel, there may be chance of collision occur. Due to that collision, the data frames may be lost. If we send multiple frames at a time, there may be chance of getting a loss of the data frames. So that we are going to use the random access protocols. These are the different types of random access protocols. Those are Aloha, CSMA, carrier sense multiple access. CSMA by CD is nothing but carrier sense multiple access, collision detection. CSMA by CA is carrier sense multiple access by collision avoidance. These are the protocols in the random access protocols. First, let us see what is Aloha. Aloha random access protocol is mainly for the wireless LAN. Wireless LAN is nothing but the local area network. Wireless local area network mainly for the shared medium to transmit the data. Using this particular method, any station can transmit the data across the network. Any station, it can transmit the data simultaneously when the data frame set is going to be available for the transmission. That is the Aloha. What are the main rules for the Aloha here? Any station can transmit the channel anytime. So this is the channel. Any station, any user want to send the data at any time. Anytime you want to send the data, you can send the data. It does not require any carrier sensing. Means before, suppose what we said previously, suppose if you want to send the data using this particular channel, first we have to sense, means we have to check whether the channel is busy or idle. But here it is not checking. It does not require here in Aloha of any carrier sensing. And collision and data frames may be lost due to this. Means we are not checking the channel whether it is going to be idle or busy. That's why the data frames may be going to getting the lost during the transmission of the data through the multiple stations. So acknowledgement of the frames exist in Aloha. Means every sender is having the acknowledgement from the receiver. That is the acknowledgement is going to be done in the Aloha. At the same time, it requires the retransmission of the data. Suppose if I send the data, but it is going to be lost due to the collision and crosstalk, that's why we have to retransmit the data frame after some random amount of time. Is nothing but, suppose if the sender is sent to the receiver, after some time it will wait some time, but it will not receive the acknowledgement. That time it will again send that frame. It will again retransmit the frame after some random amount of time. Is nothing but, these are the some rules for the Aloha. This Aloha is divided into pure Aloha and slotted Aloha. First, we have to see what is pure Aloha. Pure Aloha is talking about the whenever the data frame is available sender over a channel at the stations, we use the pure Aloha. So, means pure Aloha, each station transmit the data to a channel without checking whether the channel is busy or idle. It will not check whether the channel is busy or idle, but it will send the data. So, there may be chance of collision occur. When any station transmit the data frame to the channel, the pure Aloha waits for the receiver's acknowledgement. So, when any station transmit the data frame, pure Aloha, what it will do? It will wait for the receiver acknowledgement. If does not receive the acknowledgement specified within the specified time, again it will send it will wait a random amount of time. Suppose sender is sending the data to the receiver. It will wait for the acknowledgement whether if it is received or not. See, if it is received, okay. If it is not received, it will wait for some random amount of time. After waiting random amount of time, it will again retransmit the data. Means whatever random amount of time it will waiting, right, that is called as the backup time. So it will retransmit the frame. Here it will going to be retransmit the frame. See here in this picture. First, these are the multiple stations want to send the data using this pure Aloha technique. So first this frame want to send the data. So here all frames started at this particular time. Is here till here there is no collision, but here frame 3 started, frame 2.1 is started, here also it is started. This is the collision duration period. And coming to here there is no channel is going to be there, but it is okay. After some time, frame 2 is going to be there, frame 4 is also there. There may be chance of collision occur. Here there is no collision. So like this, the collision is going to be occur. Here is a collision is there, here is also there. Here it is free only, here it is free only whenever the data is going to be transferred. So mainly it is talking about the station is wait for the acknowledgement. It will wait for the acknowledgement. If it is the acknowledgement does not come within the allotted time, it will retransmit the data. Whatever time is waited, that is called as the backup time. At the same time, the throughput of this pure Aloha is going to be maximized. This is about the pure Aloha. So this pure Aloha means here the time is 2 into TFR. TFR is nothing but vulnerability time. And it is going to be talking about the formula for throughput is G into e power 2 minus 2G. This is for where G is the number of stations wish to transmit the same time. And the maximum throughput is 0.184. And it is also G is 0.5. This is about the pure Aloha. See here in this picture, this is a vulnerable time. Suppose if A is want to send the data from sender to the receiver. See here, why it is going to be 2 into TFR is nothing but this is the one TFR, this is another TFR. That's why it is 2 into TFR. That is the vulnerability time. And next, slotted Aloha. Slotted Aloha is talking about it is to overcome the efficiency from the pure Aloha, we are going to use the slotted Aloha. This slotted Aloha is talking about we have to divide into the fixed time intervals. To that called slots. Means we have to give the time slot for each and every particular station. That is called as the slotted Aloha. See here in this picture, we are allocating slots for this particular frame to transmit from sender to the receiver. Suppose if they want to send the frame, they have to go for that particular beginning of the slot only. They have to enter into that particular channel. That is called as the slotted Aloha. So these slot to slot 3 here, these two came in one slot only. So here the collision is there. Here the collision also there. Here there is no collision. Here there is no collision. Here there is no collision. These two only collision is going to be occurred because these two frames comes under same slot only. That is called as the slotted Aloha. And next, this slotted Aloha is these two are going to be collided each other because these two came in only one time slot. That's why it is called as the vulnerable time is TF, T into FR. So here the throughput is G into e power minus G. It is sending data allowed at the beginning of the slot only. Whenever want to send that particular frame, that is going to be started at time slot. Beginning the time slot only, it is going to be entered into the channel. That is the main thing in slotted Aloha. So in this picture, vulnerability time equal to frame transmission time. And the maximum throughput is 0.368 for G equal to 1. This is about the slotted Aloha. It was developed to improve the efficiency. We are going to use the pure Aloha and slotted Aloha. So these are the differences between pure Aloha and slotted Aloha. It can transmit anytime. It can transmit only beginning of the time slot only. Here the time slot is there. Within that time slot only it is going to allow the channel for sending the data. Here there is no time. Anytime it can access. The time is continuous, not globally synchronized. Here it is going to be discrete and it is going to be synchronized. Vulnerability time is 2 into TFR. Here the vulnerability time is only TFR, and here is the probability of the successful transmission. The formula is G into e power minus 2G, and here it is G into e power minus G here. So maximum efficiency in this pure Aloha 18.4. Here the maximum efficiency double to this is nothing but the 36.8. And the main advantage in pure Aloha is simplicity in implementation, and main advantage here is number of collisions to half and doubles to the efficiency of the pure Aloha. These are the some differences between pure Aloha and slotted Aloha. And coming to the summary, we discussed today what is channel allocation problem, what are the different channel allocation techniques like static channel allocation, dynamic channel allocation, and next we discussed what is multiple access protocols, what are the different types of the multiple access protocols. In that we are going to discuss about random access protocols. So we discussed what are the random access protocols. In that again it is going to be divided into 4 protocols. Those are the Aloha, CSMA, CSMA by CD and CSMA by CA. In today's session we discussed what is Aloha, what are the different types of Aloha like pure Aloha and slotted Aloha, and we discussed what are the differences between these two. We discussed it today's session. Next session we discuss about CSMA and CSMA by CD and CSMA by CA. These all we discussed in next session. Thank you.